Hello students, in this session
Let us have a question of simple stresses. The figure below shows a steel rod of 25 mm square cross-section area. It is loaded at 4 points KLMN. Assuming E equal to 200 gigapascal, the total change in length of the rod due to loading is. This we have to find out. So this is the question of simple stresses. This question was asked in 2004 GATE exam. It has a cross-section area of 25 millimeters square, and the load are applied at different points. Leftward load applied to 100 Newton at K point, rightward load applied 250 Newton at L point, again leftward load applied at M point 200 Newton, and again rightward load applied at N point 50 Newton. Dimensions are also given to us. So here we have to use the principle of superposition, and we have to find the total deformation, total change in length due to these applied loads. The E of the steel is also given to us. Options are given to us. We have to select the correct options out of these options. So let us solve this problem.
we have given a steel rod at which following loads are given, like 100 Newton is applied at K, 250 is applied at L section, 200 is applied at M section, and 50 Newton is applied at N section. The length of the each section is also given. Total length of the rod is 1700 and we are also given with cross-sectional area of this steel rod 25 mm square, and modulus of velocity of the steel is 200 gigapascal. We have to find out the change in length in the steel rod when these loads are applied, right? And body is in static equilibrium. It means that total load in leftward direction and rightward direction should be equal. So let us check that. This is 100 leftward, 200 leftward, this is 300 leftward and 300 rightward. 250 plus 50, 300 rightward. The body is in static equilibrium. But what load is applied at KL, what is the force in LM, and what is the force in MN, right? So what we can do is we can divide this into three parts. Let us say this is one part, this is second, and this is third. Let us divide this steel rod into three parts, and the total deflection in the rod will be equal to the deflection in 1 plus deflection in 2 plus deflection in 3, right? So principle of superposition we will use here, and to find out the total deflection, right? So let us say this is the one part KL, another part we are making just below it, this is LM, and the third part is MN, right? So KL, LM, MN. Now we have to see what load is acting on these parts so that the body will be in static equilibrium. So we can say that there are some points which are not common to any other section, right? Like here K is not common to any other point, N is not common to any point, but L is common. So we have to see that L is common here, but the total load on L should be 259 Newton rightward, and M is common, so total load on M is 200 Newton leftward, right? So but K and N are not sharing any point with other section, so whatever load is given here, that same load will be acting at the broken section, right? So it is 100 Newton here, 100 Newton here, so it will remain 100 Newton because the K is not common to any other point, right? And also N, what is the force on N? 50 Newton. So here definitely the force will be 50 Newton, and it will remain 50 Newton because N point is not common to any section of the beam bar, right? So 100 Newton, 150 Newton. Now because the body is in static equilibrium, each part of the body is in static equilibrium, 100 Newton leftward is there, so there should be 100 Newton rightward so that the body may be in static equilibrium. So 100. So in one part now we know that the force acting is 100 Newton. In third part, if 50 Newton load is rightward, there should be 50 Newton load leftward so that the body may be in static equilibrium. So we now know that in third part the 50 Newton load is applied, right? But what is the load on second part? On second part, we know that the total load on L is 250 Newton, but here we have applied 100 Newton. What load should we apply here so that the total load become 250 Newton rightward. So 100 Newton rightward is already applied. We have to apply 150 Newton rightward. 150 Newton rightward, so that this 150 and this 100 should become 250 Newton, which is the actual load here, right? So you should know that the this load and this load in rightward direction should become 250 Newton, right? So we can see here 150 rightward and 100 rightward, these two will become 250 Newton, which is already there, right? And if this is 150 Newton rightward, there should be 150 Newton leftward, so that the body may be in static equilibrium. So 150 Newton leftward. And we can check also that at M point total load is 200 Newton. So total load is 200 Newton leftward. So 150 at M point, this in LM, and 150 in MN, right? So these two loads, sum of these two loads should be 200 Newton leftward, which is there, right? So 50 plus 150 leftward, right? So now we know that KL has 100 Newton load, LM has 150 Newton load, but it is compressive, and MN has 50 Newton load tensile, right? KL also has tensile load. So now we can find out the total deflection delta L, that will be the delta L1. We know the formula, basic formula. The change in length is given by PL upon AE. This you should remember. PL upon AE. This is the basic formula. So delta L will be equal to P load in 1, L of 1. Area is common to all the sections. Area is common. E is also common. We can keep AE. P2 L2 upon AE plus P3 L3 upon AE. So this is our basic formula. We have applied principle of superposition. Now P2 is negative, keep in mind, right? So P1 here is, now if we were write here, P1 is given to us, we have calculated that 100 Newton is there. It is tensile, we are taking positive. P2 is minus 150 because it is compressive, and P3 is 50 Newton and it is tensile, right? So delta L, put values and get the value of delta L. So simple. So change in length is P1 is 100 multiplied by length L1. What is L1? L1 is this 500 mm. This is L1, this is L2, this is L3. L1, L2, L3. This is 500, this is 800, and this is 400, right? So multiplied by mm, we are keeping in mm, millimeter, so that answer may come in millimeter, divided by 100, 500 divided by area. Area is 25 millimeter square, we can keep in 25, and E we can use in megapascal. So 200 multiplied 10 power 3 megapascal, right? So the answer will come in millimeter now, right? Plus P2 is minus 150 into length 800 divided by area is 25 multiplied by 200 into 10 to the power 3 plus P3 50 multiplied by length 400 divided by area 25 and 200 megapascal, keeping megapascal here. Solve it and you will get the value of delta L. Use calculator and solve it. It is because negative, and it is higher value. You can see here the higher load 150 and higher length, both are higher. So answer is coming negative value. It means overall there is compression. Overall it is compression, right? So answer will come in, answer is given in micrometer also. So this answer is, you solve it and you will get the answer in minus 10 micrometer. Solve it and answer will come in millimeter, convert it into micrometer and you will get the answer. So this is the answer of this question, that is minus 10 micrometer, and this is option B. Answer is option B, right?